Okay. Hi. So today I'm going to be doing Codeforces Round 841, Div 2 Problem D. I still wasn't, I didn't finish Problem C yet. I'm still stuck with doing XOR and finding number of subarrays uh, for a given, that have a given XOR value in linear time. But yeah, I will look at that at some point this week. Right now, I'm going to be doing problem D, and yeah, this was suggested by a subscriber. So I've given myself 1 hour to think about something. Let's go. Valiant's new map. And the city of Mumbai, nice. N cross M cellular grid. Y keyboard. This time DVC wants to make a map. Each building inside the square has at least height of. Ah, okay. The question was easy to understand. Maximum possible. And okay, 1,000 test cases. Sum of all m into n. The sum of m into n overall test cases. Okay. Number of cells, basically, overall test cases doesn't exceed 10 to the 6. Ith line of the next. Integers. Billings. That's interesting. Okay, before looking at test cases, you want to think The problem is simply stated. One thing I notice is if a square satisfies the condition, then all previous all squares inside must satisfy the condition. That if if you have an L cross L square with height inside at least L, then all of the squares inside satisfy the condition. Or this is all squares inside answer square. Oh, let me share my satisfy condition. Okay. Okay, let's do examples. 2, 3, 4, 5. 3, 4, 5. So it's obviously 2. 1, 2, 3. So it's 1. 4, 4, 3, 2, 1, 4. This is also 1. 5, 6. Right, this is 3. Looks like, okay. Maybe this is one example we can play around with. 1, 9, 4, 6, 5, 8. 9, 4, 6, 5, 8. 10, 9, 5, 8, 11. 42, 32, 8, 11, 1. 5, 3, 1, 9. By any chance, if there was a way for me to find the maximum of a square in O of 1, a square, if I could do that in O of 1, is it enough to solve the problem? Let's see. Um, how do I know how many squares of each? Let's see. What are the number of squares of size L? If you are of size L, then the number of starting points, so this is M. Sorry, M. Then you have M minus L plus 1 into N minus L plus 1, right? So for instance, if you have 3, then 6 minus 3 plus 1, 4 starting points. And 5 minus 3, 2 plus 1, 3 starting points. So there is M minus L plus 1 into and this sums, I mean, I feel like I have a feeling that it will be too much. Like it'll be of the order M cubed. But why do I feel that? Because summing overall L is like multiplying this L times, right? M into N into L. Yeah, that's what I feel, but let's confirm. Because if this is true, then all I need to do is worry. If this is reasonable, then all I need to do is worry about how I can keep a max. Sorry, a minimum, right? Yeah, keep a cumulative minimum, which I can separately think about. So sum L is equal to 1 to minimum of M comma N. So let's assume that, assume M less than equal to N. M plus 1 times N plus 1. Yeah, is there like some obvious thing I'm missing? Like, oh yeah, maybe. worst case, if m was 10 cubed and n was 10 cubed, be 10 per 6 into 1 plus 2 and so on up to. Okay, let's actually is equal to equal to 1 to m n minus m l plus m minus l n plus l squared minus l plus n minus l plus 1. And sum, I know what it is. I don't know if this is useful. What am I hoping? I'm hoping that the number is actually of the order of something like 10 to the 6, right? Is it obvious? And at least if there's some way I can say it's obvious that it's of the order. Okay, let's finish this. That's fine. M squared n plus m plus m square plus oh sigma L square yeah, I think I'm hoping something cancels out. I'll try this for a bit. Hmm, and another. Okay, I'm going to stop this here. I feel like I'm not going to keep simplifying, and I'm still going to be left with some sort of m cubed or m square n term, which is too much. So I'm going to stop it there and say that that's not possible. And I'll come back to it if I feel like I really want that to be square. Okay. What are like the like constraints or like constants here? Hmm. Okay, what eliminates squares, I guess, if you like one, you don't have to check for the square. Mm, mm. How am I even thinking? Let's try to be systematic. So first I tried to compute total number of squares. I left that midway because I think that things won't cancel out. And I'll be left with some m cubed term. I don't have anything else to do, so let me finish this. Oh, Okay, cancellations here become 6m minus 6m 3nm square three m cubed 2m cubed any other m cubed no minus m cubed 6m square minus 6m square oh shit. Actually, let's restart. Let's ensure this is correct and then all of this looks correct. Okay, 6m square n. Do I have an m square n anywhere else? I should. Okay. 3m square n. 6m. What are my other m's? 6m minus m, 5m minus 6m. 6 minus 6 minus 1. So minus m. That's all of the m's. 6m square, 5m square, 5m square, 7m square, 4m square, 6m square. So 6 minus 6, 0. 2 minus 4 minus 2m square. Okay, great. 2m cubed. minus 3m cubed minus m cubed 6mn minus 3mn plus 3mn. Okay. So 1/6 of this. Now, worst case. Let's say if you have, so we do have a bad term here. We have 1m square n term. But oh, it doesn't get cancelled, right? Say m is 10 cubed and n is 10 cubed. You still have 1m square. So you have, let's say, let's let m is equal to 10 cubed and n is equal to 10 cubed. Then you have 3 into 10 to the 9 minus 10 to the 9. This minus. So you still have a bad term. So, which is, I guess, expected for this. Definitely after this, I need to think about how to ensure I get intuition for figuring out it's bad right at the beginning. Therefore, but now I feel like way more confident that just, I guess, going over all squares is not possible. Okay. How to get intuition for this in the beginning. I feel like I know it's the case, but yeah, something was telling me, but I didn't know how I knew. Like, I feel like how when you sum up n numbers, it's still n square. So, oh, maybe I could have used that same idea. Yeah, it's like if you take L going from M to 1, it's like summing up 1 to M and summing up 1 to N. Yeah, that's like so much better. Instead of doing all this. Okay. Yeah, I'm nowhere close to even doing the question, but at least instead of that, what I could have done is I had sum over L m minus L plus 1 into n minus L plus 1, right? I guess I was also hoping that this mn equals 10 power 6 maybe gives us something. But all I needed to do is show in the worst case it's not possible. So, like, yeah, you can get some intuition that maybe if both are 10 cubed, it would be bad. So let's just let m equals 10 cubed. And if you do sigma L, m minus L plus 1 times n minus L plus 1, you can imagine L going from m to 1. Whole square, right? This is the same as some k is equal to when L is equal to m, you get 1. And when L is equal to 1, you get m. Right? And then sum over the first n squares is definitely has a cube term. So what I can do, this has n into n plus 1 into 2n minus 1. So this has a cube term, 2n cubed, that can't be subtracted, right? Subtracted. So this is like order m cubed, which is we know is bad. So this is, I guess, how I could have gotten that whole shenanigans. But yeah, I wasted time. That's okay. Um, okay, now that we know we can't do this, let's think. Okay. Um, ideas. Is it like some sophisticated binary search? Can you think of? If one sec, I'll come back in a minute. Okay, what do we know? Okay, time up. I'll give myself another 5 minutes. if we know the best square, the solution for size m comma n, let's do the whole. If we know the solution for size m comma n, then what is the solution for size m plus 1 comma n, m comma n plus 1, and n plus 1 comma n plus 1? Let's see. If you have this, so we need to store the sorry, yeah, the for nm, it's n rows, n columns, right? So n comma m plus 1, n 1 comma m, and then n plus 1 comma m plus 1. If you have this, what are these, right? Okay, if you have the solution for size n comma m, and you want for n comma m plus 1, if you also store like the square's endpoint, say. Now, if okay, let's say the solution was here, not overlapping with the endpoint. The solution is somewhere here, and if you extend, it will be less than that. So then obviously the solution remains the same. Is that obvious? Because you just added one column, right? So if this, so I'm going to give, I feel like I'm close to something, so I'm going to give myself like 20 more minutes. Or do I have, yeah, I have 20 more minutes. Hey Google, hey Google, set an alarm for 20 minutes. Okay, how could I have like a bigger square than this? The way I could have a bigger square is either ah, oh, my brain's tired. Okay, here we are. So we're doing this. Say case one, the best solution. You added this. The best solution is like ends here. And there's one more here. Then you can, the maximum is either like this or this extra or the original, right? Basically, if it's like this or this. Yeah. Okay. These two cases, you have this. If it is this, case two that I can think of. This whole thing. Then same as before. Okay. Case three, where it's not touching the border at all. Now what happens? Um, it's somewhere here. Say, if you need like a bigger square, this is the difficult thing for me. Where is the square? So if you need a bigger square, let's say, so okay, can we agree that the square size can at most, if this is M, it can be at most, okay, let's not, if this is K, it can be at most K plus 1, right? Because if it's greater than K plus 1, for instance, if by adding this I'm getting something that is K plus 2, that means since this is only 1 and this is 1, there's already a K plus 1 cross K plus 1 square inside, and this is not the biggest square. So the size can at most be K plus 1. And if it is K plus 1, it means that, oh shit. If it is K plus 1, it means the way, see, we only care about if it's K plus 1. If not, you can screw yourself. I mean, the square can screw itself. So yeah, so I think that's my headphones. I don't know what's going to happen to recording. But so yeah, so if it was K plus 1, it means there was a K cross K here, right? So then if I pick like the rightmost guy, then I'm good, right? If the like rightmost best square is always, yeah, if the rightmost, pick, that's fine. So yeah, if the rightmost thing is here, then yeah, then it's the same. But now you're worried about making the new rightmost, right? So not only do you want to save a K cross K, I mean, square here, yeah, but see, but for instance, if there was a K minus 1 cross K minus 1 square here, then you want to save that as well. The reason being, you need that to ensure you get, like in the next turn, you get the rightmost K cross K. I see. But each time, how much time will this take to check? See, for each mn, if it's going to take L time, that's not good. We just saw. If I can get this range minimum in O of 1, yeah, then I guess I can do this. And this one's minimum in O of 1. Yeah, if I can get every assume I can get that, then or can you do like a rectangle minimum thing? I feel like, what if I don't? Anyway, such dark thoughts will not be entertained. Can you get minimum? Da-da-da-da-da. Plus this minimum and this minimum. That's true. Yeah, you can easily find minimums for like the whole rectangle. Right, because if you need to find a minimum for this rectangle, all you need to do is minimum up to here, which you should have found out, and minimum up to here, which you should have found out, and this minimum. Nice. So you can find, yeah, of the whole thing. Can you use this to find minimums of arbitrary? Yeah. How do you find? Wait, just for like a simple array. If you know minimum from here to here, and like everywhere, if you want to find this minimum, is there like a way to do it? So suppose this minimum was 6, let's say, and this minimum is 3. Then obviously this minimum is 3. This minimum is 6. And including this minimum is 7. Oh, sorry. Yeah, if this A, B, C, if min of A is 6 and min of B is 3, then 3 must occur somewhere here. So then min of C equals 3. And this can't be higher than 6. B can't be higher than 6 because it's always decreasing. And if it's lower, it's just that. Yeah, minimums always get lower or stay the same. And if they stay the same, you know that, oh shit, that's the issue. If min of A is 6 and B is 6, then C is what? We don't know because yeah, because C could have like 7, 8, 9, and this whole thing would still be 6, but I have no information about this. Shit. Yeah, I don't think if you do the cumulative sum trick works for minimums. What do you do to find minimums in a range? I feel like I know this. Do you do segment tree? I think you do segment tree. Yeah. Yeah, I think you need to do segment tree for this. Okay, I will stop working on this now. But okay, some ideas, I think. If it's something obvious that I completely missed, I'll be yeah, so that you get log n queries for anything of length n, right? I'm sure it's segment tree. Yeah, I guess this stopped working. Okay, let's give up. Let's look at the solution. On Q. Did I like completely miss? For a particular size, how to check if there's a cube greater than that? I don't. You just check that every element's greater than that.
into binary search on side length. Oh my god, this is just like, yeah, that's true. It's like a binary search thing. Oh shit. Um, oh my god. Yeah. So I guess if um fixed a particular length, looked at all squares of that length, can get at most mn squares. I do that log L times. Now for mn squares, so that, of course, it's binary search. How did I forget this? But now still like how, for all those mn squares, how can you find the minimum in like of one? For do you need to, I don't know. Yeah, that part I don't know. Wow. That's so nice. Okay. So it's like yeah, I need to think about this for a bit. Yeah, but it was a fun problem, and I realized I mean, it took some time to just do complexity to see that it doesn't work. Yeah, this time could have been saved. Like, this is obvious. I I know it's like yeah, so MN, so instead of the MNL, they saved on the L and did log L. I guess, yeah, that's an obvious thought. This is good. Then I was thinking if, but yeah, these had like so many cases. And I guess the key here is for a given square, how to find fast whether it satisfies the constraint, which is this prefix sum approach. Yeah, need to think about that. Okay. See ya.